So in this problem, we have to find domain and range of the given function of two variables, and later we have to sketch the graph of the function. So the function is given by this rule, f function of xy, and then rule is its value is 6 minus 3x minus 2y at any point xy, and let this be z. Now since we are doing calculus, all these x, y and z will be real numbers. Now what will be domain of this function? Suppose we are denoting domain by d set. It will be collection of all xy points. Of course these are ordered pair, so they will be in xy plane, such that the rule z equals to 6 minus 3x minus 2y. When we apply this rule, z is well defined real number. So all those xy point in xy plane, okay, when we plug in it in this expression, the value of z must be, it should be well defined and it should be a real number. Now in this case, x and y can take any real number, be it positive, negative or 0. In each case and each combinations of xy values, z will be always well defined. That is, there will be no something like 1 over 0 like situation, and it will be always a real number. So in this case, the domain will be entire, this will be entire xy plane, right? X will take value, x will take values in this interval minus infinity to infinity, and y will take values from the entire real number system. So this one is the domain of the function. In fact, this one is entire xy plane. What about range of function? Now range of function will consist of all these z real numbers. Of course it will be one dimensional, such that z we obtain from this rule 6 minus 3x minus 2y, and xy are taking values from domain. And what is domain? Domain is entire xy plane. So what will be the z values? Now since x and y variables can take any real numbers, be it positive, negative or 0, so the corresponding z value will also be any real number. Okay, so the range of the set will be entire interval minus infinity to infinity. So this is the complete set of real numbers. So the function f, which is given by this rule, it has domain the entire xy plane and range the entire system of real numbers. Now next we have to sketch the graph of this function. Now what is the definition of graph of a function? Graph of a function is collection of all xyz points belongings to the space, such that xy are taking values from the domain and z is taking value from the range set. The graph of function is collection of all these triad of numbers which satisfy these two conditions. So it means the graph will be a three-dimensional figure, right? So one way of doing it is like first we draw the entire three-dimensional coordinate system. Say this one is y, z, and the third axis is x-axis, and plot the domain over here in xy plane and the corresponding xyz points in the space. But for this particular function, there is one more easy method to sketch the graph of this function. Now consider this functional relation z is equals to 6 minus 3x minus 2y. In this relation, all the three variables x, y and z, they are of degree 1. So this is a linear relation between three variables x, y and z, and any relation of this type, any equation of this type, ax plus by plus cz equal to d, geometrically it represents this plane, this surface. It's called plane. And how do we draw it? We transform this general equation of plane into intercept form, and the intercept form is x by a plus y over b plus z over c is equals to 1. There a is the intercept made on x-axis, b is the intercept made on y-axis, and c is the intercept made on z-axis. Now let us convert it into intercept form. Okay, so bringing 3x minus 2y to the left hand side, this becomes 3x plus 2y plus z equals to 6. Now we have to make the right hand side equals to 1, so we'll divide throughout by 6. So this will become x over 2 plus y over 3 plus z over 6 is equals to 1. So this plane is making an intercept of 2 units on x-axis, 3 units on y-axis, and 6 units on z-axis. Let us use this information to sketch the plane in the 3D coordinate system. And these are drawing lessons for us, how to draw a plane in a 3-dimensional coordinate system. So this is y-axis. This one is z-axis. So the screen of our device is in XYZ plane. Okay, and now this one is so this is x-axis, y-axis, and z-axis. So now the x-intercept is of 2 units. So roughly this one is say 1 and 2. So this point is 2, 0, 0. Y-intercept is of 3 units, so roughly this is 1, 2, 1, 2, 3. This one is 3 units, so this point is coordinates having 0, 3, 0. And y-axis, z-intercept is of 6 units, so roughly this is 1, 2, 3, 4, 5, 6. Okay. So let us extend our z-axis. So this point on z-axis, coordinates of this point are 0, 0, 6. Now let us join these 3 points, right? So let us use a different color. So we are joining these points by straight lines. So this is the second line and this one is the third line. And let us shade this entire region between these 3 lines. So this shaded region that we are shading using yellow color, this is the plane sketch of the graph of this function. Now this is not the complete graph. This one is part of the plane intercepted by the XYZ, the first octant, right? Otherwise this plane is an infinite plane, and obviously it will be an infinite plane because XYZ, all the 3 variables are taking entire real number values from negative infinity to infinity. So finally concluding, the given function domain was entire XY plane, range was the real number system, its graph because it's a plane, so that's why we can sketch the plane by converting it into an intercept form, and using this intercept form we sketched the graph of the function. Thank you.